Let's look at multiplying and dividing radical expressions. We'll start with multiplying. And this is going to be one of those videos where you're going to see things that are the same, but they work in a kind of a different way. So if you look at example 1a, I hope that appears to be a foil to you, and it is, other than we have radicals that we are multiplying. So we say radical 5 times radical 6. We can apply the product rule. That is square root of 30. Radical 5 times positive 1 is 1 radical 5. Then we have radical 3 times 6 is positive 3 radical 6. And finally, radical 3 times radical 1 is positive, 3 times 1. No radicals here. Positive 3 times positive 1 is 3. Now, if you will notice, the next step in a regular FOIL would be to combine like terms, but none of these are like. And the only one that could be broken down is a 30, but a 10 times a 3 isn't going to help me because those are not perfect square numbers, and neither is a 6 times a 5 or a 15 times a 2. So there's no reason to break it down. So because there are no like terms, that's all you can do with that, is just multiply it out using FOIL. Now, before we go any further, I'm going to go up here in this top space, and I want to kind of show you something. If you were multiplying radical 3 times radical 5, remember that you can make that under one big multiplication and radical sign and make it 3 times 5 is 15. But if you were multiplying the number 3 times radical 5, those don't multiply together. It's just 3 radical 5. So don't confuse those two things because it can be very confusing. Let's look at the next FOIL. 7 times radical 5 is just 7 radical 5. Outside, 7 radical 2 plus 7 radical 2. Inside, minus, those are both radicals, so I can multiply them together. And last is minus radical 3 times radical 2 is radical 6. This is another example where none of the terms are like and can't be combined then. Looking at C, this should look familiar. It looks like difference of two squares. So when we do difference of two squares, if I had x plus 3 times x minus 3, we know that we would end up with x squared. Our outside and our inside terms would go together to make a 0, and we would just have minus 9. Well, watch what happens when you're dealing with radicals. A little bit different. Radical 10 times radical 10 is just 10. Think about it. It's square root of 100, but square root of 100 is just 10. Anytime you multiply a radical times itself, you just get the radicand. Just like with difference of two squares, your outside and your inside terms are going to make a 0. It's going to be minus radical 30 and plus radical 30. So those are going to go away, just like it did here with difference of two squares. But on your last, what you're going to have is positive radical 3 times negative radical 3 is going to be negative square root of 9, which is just 3. Now the difference is, with algebraic difference of two squares, you're finished. When you get down to the last two terms, there's nothing to combine. But with the radicals in this case, my 10 and my negative 3 are like terms, so I have to combine them, and I end up with just one term, 7. So you really have to pay attention with radicals when the radicals disappear, because you multiplied times itself, you end up with numbers that can combine. Let's look at this one. Square root of 7 minus 3, all being squared, means square root of 7 minus 3 times square root of 7 minus 3 times itself. Same signs. Watch what happens here. Square root of 7 times square root of 7 is just 7. Square root of 7 times negative 3 is minus 3 square roots of 7. Inside is another minus 3 square roots of 7. And now my last is negative 3 times negative 3 is positive 9. And I again have like terms to combine more than you would if this had been an algebraic squaring a binomial. So a 7 and a 9 is a 16. A negative 3 of those and another negative 3 of those is negative 6 radical 7. So those did not make a 0. I was multiplying by the same signs here, whereas here I was multiplying by opposite signs times itself. So please note that difference. Here, again, using FOIL, looks like difference of two squares, but these are cube roots. So watch what happens. First, outside plus 5 cube roots of 3. Inside minus 5 cube roots of 3. Now here's where it's interesting. Negative times positive minus cube root of 9, which is not 3 because this is a cube root. So the only time multiplying the radical times itself one time caused the radical sign to go away and just leaving me with 10 is when it was square root. These do make a 0, and I'm left with 25 minus cube root of 9, and I can't simplify that. Here, square root of k times square root of k is just k. This is going to be minus square root of kz. This is going to be plus square root of kz. And this is going to be minus square root of z squared, which is just z. Outside, inside terms make a 0, and I have just k minus z. Okay, that's multiplying radicals. It's not difficult, you just have to be careful. Let's look at dividing. Dividing is a little odd because there's a rule that says it is not considered simplified if you still have a radical sign in the denominator. It's okay to have one in the numerator, but not in the denominator. So the process of removing the radicals from the denominator so that the denominator contains only rational numbers is called rationalizing the denominator. So let's look at how that can happen, because you can't just take it away. We noticed in these problems in multiplying that when, let's use the tens as an example, when you multiply a square root times itself, you ended up with just the number with no square root. And the reason was you would have gotten square root of 100, but square root of 100 is just 10. So we're going to use that idea that if you have a radical sign in the denominator, a radical expression, to get rid of it, if it's just a monomial, we are going to multiply by itself over the same thing, because that will cause in my denominator, square root is 7 times square root is 7 is just 7. So I got rid of the radical sign. In my numerator, I have 3 square roots of 7. And so I accomplished the goal by rationalizing the denominator. This is considered simplest form. This is not. Now be careful again. You cannot cross cancel a number outside the radical with one inside. You can't do that. Here, to rationalize the denominator, I'm going to multiply by square root of 5 over square root of 5. That's going to give me 5 square roots of 10, square root of 2 times square root of 5, over 5. That just becomes square root of 25, which is just 5. Now, here's where you can cross cancel. I can cross cancel numbers on the outside, coefficients. So this 5 goes into 5 once, it goes into 5 one time, and I end up with just square root of 10. What I cannot do is cross cancel this 5 with the 10 inside the radical sign. Let's try another one. it says simplify each radical. So we're going to look at simplifying and not leaving any radicals in our denominator. So we know at the end we'll stick a negative on. I know I can split this into two small radicals. Now I don't want to multiply by square root of 125. I know I can break that down. So before I rationalize the denominator, I want to simplify what I have. So this is going to be 9 times 2. This is going to be 25 times 3. That's their perfect square factors times their factor partner. This comes out and makes a 3. This comes out and makes a 5. So now I have 3 radical 2 over 5 radical 3. Now I can rationalize that denominator by multiplying by just the radical part. This is still a monomial. So square root of 3 over square root of 3. In my numerator, I have 3 square roots of 6, 2 times 3. In my denominator, I have a 5 times 3 times 3 would be square root of 9, which is just 3. So I have 3 radical 6 over 15. Now I can cross cancel, and I end up with square root of 6 over 5. All right, let's look at this last one. Oops, you know what we forgot on A? We forgot the negative sign. There's a negative out front of each one of these steps. See, I just demonstrated how easy it is to forget that. So there's a negative out front. It didn't change our process, but it is part of the final answer. And the reason I thought of it is this one also has one. So we'll do better this time. Here I'm going to split this into two small radical signs, but I'm going to go ahead and break down 50 into 25 times 2. I don't need to break down the M4 because it's already divisible by the index. I'm going to leave it as M4 over. Down here, I am going to break that into something divisible by the index of 2. So P4 times P1. I'm going to pull out the 5, pull out the M squared. Here, I'm going to pull out P squared. So what's left is negative 5 M squared square root of 2 all over P squared square root of P. Now, you might think you're finished, but we're not because we have a radical in the denominator as part of a monomial. So I'm going to multiply by square root of P over square root of P. In my numerator, I'm going to have negative 5m squared square roots of 2p over, now let's look at what we have here. We have a p squared. When I multiply these two, that's going to give me another p. So p squared times p is p cubed. That was a fairly difficult problem. All right, let's look at rationalizing the denominator when you don't have a monomial in the denominator, but you have a binomial, and part of it is made up of a radical term. So it says whenever a radical expression has a sum or difference with square root radicals in the denominator, rationalize the denominator by multiplying both the numerator and denominator by the conjugate. It's called the conjugate. And here is what a conjugate is. If I have difference of two squares, let me just do it algebraically. And here I have x plus 3. The conjugate is the piece that goes with it with the opposite sign. So this is the conjugate of this, and this is the conjugate of that. So it's the same thing with opposite sign. If you just multiply by square root of 2, it's not going to get rid of the radical sign in the denominator, because what would happen is you would have to distribute it to both pieces and you would end up creating another one. So in this case, what we have to do is we have to multiply by the conjugate. And the conjugate of 1 plus radical 2 is 1 minus radical 2. And you do the same thing in the numerator. Rather than going ahead and distributing that numerator, I recommend that you leave it as just 3 times 1 square root of 2. You don't have to distribute it. Now in the denominator we do. We have to FOIL. So we're going to say 1 times 1 is 1. My outside inside terms are going to make a 0, but then my last is going to be minus square root of 2 times square root of 2 is just 2. And then I simplify that to being 3 times 1 minus radical 2. 1 minus 2 is negative 1. Now, although that is a correct answer, it's awkward because we're dividing by negative 1. It would be easier to put the negative in that numerator and say it's negative 3 times 1 minus square root of 2 over positive 1, meaning I don't really have to show it. Now notice, when I divided by the negative, this sign should have been changed also, because think about it. If I had distributed, it would have been positive 3 minus 3 radical 2 divided by negative 1. The whole thing is being divided by negative 1. So if you distributed, this becomes a negative, this becomes a positive. When I don't distribute, and I realize here I didn't distribute, so I just told you incorrectly, that should have stayed a negative. It becomes positive by the negative 3 being distributed. So let's rewrite that correctly. Negative 3 times 1 minus radical 2, because that negative 3 gets distributed. So if it's easier for you to do it by just actually distributing the 3 and then dividing by the negative 1, making it positive, you may do that. You got to be careful of this one. You can see I just about stumbled on it because it's very tricky with those negative signs when you're dividing by a negative 1. Let's look at the next problem. We have 5 over 4 minus square root of 3. We're going to multiply by the conjugate of the denominator, 4 plus square root of 3, 4 plus square root of 3. Again, I'm going to leave the numerator without being distributed, so 5 times 4 plus square root of 3 over, here I'm going to have a 16. My outside inside terms are going to make a 0, and then I'm going to have minus square root of 3 times square root of 3 is just 3 because it's square root of 9. So that is over 13. Notice that was easier than the last one because we didn't have the issue of actually dividing through by negative 1. All right, finally here with this section, I have a binomial in the denominator, so I'm going to multiply again by the conjugate of that denominator. So square root of 5m plus square root of p over square root of 5m plus square root of p. That is the conjugate. It's the same thing, different sign. So your sign should be opposites. In my numerator, that's going to give me a 3 distributed to square root of 5m plus square root of p over, let's see what we get when we multiply here. Square root of 5m times square root of 5m is just 5m. My outside insides make a 0, and my last term is minus square root of p squared, or just minus p. That one looked like it was going to be terrible, but it actually wasn't. It turned out to be fine. All right, let's look at example 5. Here we're going to simplify, and this is really something that you have to watch carefully, and it has to do with when you can cross cancel and when you can't. So I'm going to use some different colors to show you something here. I have 6 plus 2 radical 5 over 4. There are 3 terms here. The 6, that's the first term. The 2 radical 5, that's the second term. And the 4, that is the third term. And the only way I can cross cancel is if there is something that goes into all 3. So what goes into 6, 2 radical 5, and 4. The only thing that goes in is a 2. So 2 goes into this 3 times, 2 goes into that 1 time, 2 goes into that 2 times. And I'm left with 3 plus 1 radical 5 over 2. So you cannot just cross cancel these two parts, the 4 and the 6. All 3 pieces have to be able to be canceled. Next one is more complicated because I have to simplify what's under that radical first. So I have a 5y minus, I'm going to break down my 8 into a 4 times 2, y squared is already good, over 6y. Don't even think about cross-canceling those y's. I can't do it yet because there's a third term involved. Square root of 4 is 2. Square root of y squared is y. So I have 5y minus 2y square root of 2 all over 6y. Let's look again at the 3 terms. There's 1 term, 2 terms, 3 terms. What's the only thing that goes into all 3? It is a y. So these y's can cross cancel because they all have 1. And I end up with 5 minus 2 radical 2 over 6. Please look carefully at this answer. A couple things that you can't do. I can't say 5 minus 2 is 3. I can't do that because it's similar to 5 minus 2x, and you know you can't combine unlike terms. I also can't cross cancel the 2 and the 6 because the 5 doesn't have a 2 that goes into it. So remember, you can't cross cancel unless all 3 terms have a common factor.